Today we're looking at identifying proportional, non-proportional relationships again, but this time with graphs. So when I look at this table, we're going to look at proportional and non-proportional with tables again, and then we'll go back and we'll look at a graph. When we look at this, we've got candy bars sold as our X value, and our Y value is money received. Now the money received depends on the number of candy bars sold. So Y depends on X here. It's the dependent variable, and X will be the independent variable. We can also look at this as a rate, a unit rate, and so it's going to be dollars per bar. So how much money does this cost per candy bar? Or Y over X is the way we always put it. We always put the dependent variable in the numerator. So when we look at this to see what our unit rate is actually going to be, we'll take 3 and divide it by 2, and we get 1.5, or 1. We're going to go and make that 1.5 because we're talking about money, so that's $1.50. And then 5 divided by 4 is going to be 1 1/4, or 1.25. And then 9 divided by 8 is going to be 1 1/8, and then 12 divided by 12 is going to be 1. So none of these are equal. We could have stopped right here when we got $1.50 and $1.25 as the unit rate and said these are not proportional because the unit rates are not equal. Okay, what's not proportional to what? The amount of money received is not proportional to the number of candy bars sold. So now we want to go down and we're going to make a table where they are proportional. So if they are proportional, then we're going to start with 2 to 3. So actually 3 to 2, $3 for every 1 candy bar, or 2 candy bars sold. And so I got to come up with proportional relationships. Well, I could go to multiply by 2 and 2. That'd be like multiplying by 2 over 2, and I'd get 4 and 6. So 6 candy bars would cost $4. Let's go to 3. If I had 3 candy bars, how much would that cost? Well, we know 3 divided by 2, the unit rate is $1.50. So it's going to cost $1.50 per bar. So if I add $1.50 to 3, I'm going to get $4.50 for 3 candy bars. If I add $1.50 to $4.50, I get $6 for 4 candy bars, and 5 candy bars with them would cost $7.50. I could also take my $1.50 and multiply it times 2 candy bars and get $3. Take $1.50 times 3 and get $4.50. 4 times $1.50 is $6. 5 times $1.50 is $7.50. All of those show us that our unit rate for each one of these, $4.50 divided by 3, would also be $1.50. 6 divided by 4 would be $1.50. 7.50 divided by 5. So my unit rate, I can either divide Y by X to find the unit rate, or I could multiply X times the unit rate to get Y. And we know all that because we know that Y is equal to K times X, and K would be our unit rate, or our rate of change. So now we're going to graph that. We haven't graphed in a while. We did a little review on that earlier, but it's been a while. So let's plot these points. So when I plot the points, I've got my X is 2 and my Y is 3. And then I'm going to plot 3, 4.5 or 450, and 4, 6. And then I'm going to plot 5, 7.5 or 750. And my X's always come first in my order pair, my Y's are second. When I look at my graph, my Y coordinate is always on the vertical axis, and my X coordinate is always on the horizontal axis. Remember, this is independent, and up here Y is dependent variable. So when I plot these, if I plot 2 on the X, go up to 3 on the Y, and then 3 candy bars cost $4.50, so I go halfway between 4 and 5, and then 4 candy bars cost $6. And 5 candy bars cost $7.50. Now, if I went down and did one candy bar, well, I know one candy bar costs $1.50 because that's the unit rate, $1.50 per one bar. So if I go one, I go to $1.50. What if it was zero? If I had no candy bars, how much would that cost? Well, it wouldn't cost anything. So there we're at our origin. And so if we connect these dots, and if I had a straight edge, it'd be better, but that's okay. When I connect the dots, they go on, and I could do, I could figure out that 6 candy bars, that would cost $9, and I could just keep on plotting. $7 would be, or I'm sorry, 7 candy bars would be $10.50, and I could plot them all the way up, going up $1.50 each time. But it is a straight line. And so what we find out that if we have a proportional relationship in a graph, we know that it's always going to be a straight line, and it's always going to pass through the origin. So points lie in a straight line. This is down at the bottom of your page, talking about the characteristics of graphs of proportional relationships. And the line always goes through the point 0, 0, which is the origin. And you might want to put 0, 0 there just in case you've forgotten that. Okay, so now let's go to our next example. And on this example, we're going to graph the ratio in the table, the ratios in this table, and we're going to see if it's proportional just based on our graph. So we're going to plot the point 2, 3. So we go to 2 on the x, 3 on the y. That was just like that one. 4, 6, well, that one's the same also. So if we go to 4, 6, and then if we go to 8, 12, that one is also would be on this graph, because if I go to 8 times 150, that's going to cost $12. Okay, well then it goes to 12, 14. So if I go to 12 and then up to 14, I don't know if you can see it or not, but oh, here's my straight edge. Well, good deal. Okay, so when I plot these, they're exactly like the table earlier, except that when I get to 12, 14, it takes a hard right, and my angle changes. And so in that case, it does not lie on a straight line. This point right here, 12, 14. So since it doesn't, all the points don't lie on a straight line, then we have to say that it's not proportional or non-proportional. And we can tell that just because all the points don't lie on a straight line. And down here, points lie in a straight line, has to be one of them, like this one over here. So these would keep going up and up. All right, so our last example we're going to look at says graph the ratios in the table, and then we're going to determine whether it's proportional. So we're going to go to 0 on the x, so we're right here at 0, and we're going to go up to 6 on the y. Then we're going to go to 3 on the x and 9 on the y. Then we're going to go to 6 and 12 on the y. We're going to go to 9 on the x and 15 on the y. And then we're going to go to 12 on the x and 18 on the y. Now, if we see that and connect the dots, it absolutely lies on a straight line, and that's one of our conditions. But the other condition is that it has to lie or pass through the origin, and this one does not. So in this case, these ordered pairs are not proportional. Now let's look at them and just check and see. Okay, so if I take, we're not going to do 6 divided by 0 because that's undefined, but if we start with 9 divided by 3, that unit rate would be 3. And then 12 divided by 6, the unit rate or the quotient would be 2. And then right there we can see they're not proportional. 15 divided by 9, that's going to be 1 6/9 or 1 2/3. And then 18 divided by 12, That's going to be 1 1/2. So these are not proportional by looking at the unit rate, but we can also see that they're not proportional because it does not pass through 0, 0, the origin, this line. Now, you might come over here and say, but Miss Stevens, look, if I add 3 each time, they go up by 3, and you're right, they do go up by 3, okay? But when you look at their unit rates and divide the y by the x, those are not equal. You're going to see later on what this makes as far as an equation goes. It's not going to be y is equal to kx like the other ones, and you'll see why these are not proportional, or you'll see what kind of an equation they do make, because they do go up evenly here. The problem is they don't start out at 0, 0, so that's why we say they're not proportional. If we started at 0 here and 0 here and went up by 3 each and went up by 3 each, they would be proportional. Okay, so when two proportional quantities are graphed on a coordinate plane, the points lie on a straight line that passes through the origin, and my dog agrees with that. So the next thing you're going to do is, for an assignment, you're going to do your exit slip, and then we'll look at the other problems tomorrow.